In this presentation, we're going to be covering topics related to shaping processes for plastics. So to start, we have polymer melts, which from chapter 3, we know that they are non-Newtonian behaving fluids which exhibit pseudoplastic behavior. And they are important because they serve as a starting point for many plastic products. Now moving over towards manufacturing, we have first extrusion, where the polymer is just heated and pushed through a die. The general extruder machine components include the hopper, barrel, screw drive, and screw drive motor. An advantage for this process is that we can produce a high volume at a time, which allows the cost per the part to be low, but the setup cost is high.
For the two other manufacturing processes for plastics would be injection molding. Injection molding, it's done similarly to the slide before, which is heating up the plastics and then pushing it through or injecting it through a mold. Just like the next the next process, which is compression and transfer molding. Compression molding is similar to injection molding, in which the plastic is heated up and put through the mold while compressing on it, while putting some compression force. Similarly, the transfer molding is done the same way, but using higher forces. The advantage that transfer molding has over the compression molding is the tolerances for the parts done is a little bit higher.
I'll be talking about blow molding and rotational molding. Blow molding is a manufacturing technique that utilizes air pressure to expand soft plastics within a mold cavity. It is primarily employed for creating single-piece hollow plastic components, and it is mostly used for mass production in beverages industry. Secondly, rotational molding utilizes gravity with a rotating mold to create large hollow shapes, also known as rotomolding. And it is an alternative to blow molding and is commonly employed for thermoplastics, polymers, and thermosets, and either elastomers. The processes that include in rotational molding are polymer loading, heating and rotation, cooling and solidification, and extractions.
Another product of plastics are sheets and films. Film is considered stock less than 0.5 millimeters thick, and sheet stock is anything 0.5 to 12.5 millimeters thick. There are three main ways of extruding sheet and film. The first is slit die extrusion, where the melted heated feedstock is pulled through a slit die and run through a series of chilled rollers or a quenching solution. The top left picture shows this process. Another way is blown film, where air is blown through the feedstock to produce a thin film. The resulting film can be left in a tube like a garbage bag or cut at the edges. The middle picture shows this process. The final process is calendaring, where feedstock is fed through a series of rollers reducing the thickness to final dimensions. Calendared products include shower curtains and pool liners. The bottom left picture shows this process. The production of fibers and filaments are most extensively used in textiles, such as synthetics and cotton. Fibers are a strand of material whose length is at least 100 times the cross-sectional area, where a filament is a continuous fiber. There are three processes for fiber extrusion. Melt spinning is used for easily melted polymers, like polyester or nylon. An advantage of this method is high production speeds and no need for solvents. Dry spinning is applicable when the polymer needs to be dissolved in a solvent. The solution extruded through a spinneret and the strands are heated to evaporate the solvent. Wet spinning is used when the chosen solvent cannot be evaporated, instead removed by chemical means. The solution is usually extruded into a coagulation bath. This method is commonly used for acrylics and rayon.
So another process is thermoforming, which basically applies heat to a plastic sheet, and it then uses either a physical force or a pressure difference involving a vacuum to press that heated plastic sheet into a mold. It offers for very high detail at a relatively low cost. and also yet it has a lot of wasted material. Another method is casting, where usually a liquefied plastic is poured into a mold in a standard atmospheric pressure. It is a low-cost process, but it has a pretty low output rate, pretty bad tolerances, and often bad involves a trapped air bubble, which can ruin the piece. Another plastic manufacturing process is coating, where it involves dipping either a workpiece or a specific part into a liquid polymer that can create a coating for, let's say, a hammer or a softer handle. It is a low waste, low cost manufacturing method, yet it is slow due to the curing, and it also misses accuracy. And there's also polymer foam processing, where a polymer is expanded into a foam-like structure using blowing agents, and that creates cavities in the foam. A typical blowing agent could be CO2, air, or water. There are three main methods that polymer foam is created, which is the slab stock process, molding process, lamination, and spraying. These are oftentimes used for, it oftentimes creates foam-like polymers that are very good for either insulation or protection, like protecting different things from damage and packaging. Here are our sources. Thank you very much. Bye.